water and salt. So you get these two things together, salt and water. And a pH of water is 7 when the temperature is 25. We think that temperature is still 25. But just one thing is added, which is salt. And we may think that yes, salt is salt, as not acid, not base, so it should have the pH. It doesn't affect the pH of water. This we're supposed to think. But this is not totally true. This is partially true. We have types of salt. Depending on types, the salt affect the pH of salt, pH of water. So first, if this is sodium chloride, and if you add sodium chloride in water, so what do you have? Water and sodium chloride. These two are together. When you mix these two together, you have, and the ions form are sodium ion and chloride ion. They're already there, but just split ions. And for water, this splits into hydroxide ion and this ion. Water giving H plus ion and OH ion. And sodium chloride doesn't give any H plus ion and OH ion, which means that pH only depends on water. pH doesn't depend on sodium chloride, which means the pH of pure water and pH of sodium chloride is almost same. I'm giving example of another salt. Suppose this is here, you get CH3COONA, sodium ethanoate. Okay, sodium ethanoate. So when you add this in water, then sodium ethanoate dissociates to give, which are the ions it's giving? CH3CO minus and Na plus. So you get these two ions. And water is also here. Water dissociates to give, as it gives these two ions. Now, what do you think about pH of this solution? pH of this solution. And look at the ions it forms. Suppose H plus ion, which ion given by water, and that you know water alone pH 7. And this you may think that sodium ethanoate giving ethanoate ion and sodium ion. So none of them is giving H plus ion. So they get here no H plus, no OH ion. So you may still think that this is 7, pH 7, but this is not right. Okay, this will have different pH, and how this affect the pH. Look at this. Focus on this ion. I write this ion here. Pick the ion here. CH3COO minus. Okay, this is the ion, and water is also there because it is aqueous solution. And this ion and water, and this may react. And when these two react, this gives CH3COOH. COOH, right? And then this gives another thing, which is OH ion. So look at this reaction. So look carefully. This is a beaker, water, and I'm just giving here ethanoic acid. And what the products will form here? What do you think? So that we get CH3COOH, which means no change, and we'll get CH3COO minus, and we'll get H plus ions. So we get this large quantity ethanoic acid, because ethanoic acid is a weak acid. Ethanoic acid is a weak acid, and weak acid means that remains as molecule because it ionizes very slightly, which means that when you have these two things together, this and this, certainly this is more stable. Okay, this is more stable. So here you get in the solution, in this dissolving, you're adding ethanoic acid and mostly remain as ethanoic acid. Here you get two possibility in the solution. You may get ethanoic acid that you are adding there, that remains there. Another is ethanoic acid convert into its ion. There's two possibilities here. So what you get? You get most of them, not all, most of them you get as ethanoic acid molecule, because ethanoic acid is weak acid and this is more stable. Again, look at this, reverse. When you add not ethanoic acid molecule, you're adding this time ethanoate ion in water. So still here you have two possibilities. One is the ethanoate ion. What is the other? Another is ethanoic acid. So which one is more stable? You already got this. Ethanoic acid is more stable. So you will not have ethanoate ion in water. I mean, you will have less amount, small amount, because that is less slow. What I said, this is very simple. I repeat again. When you have ethanoic acid or any weak acid, and you are adding ethanoic acid in water, so what will you get? You will get mostly ethanoic acid. okay, you will get mostly ethanoic acid because this is weak acid. And you will also get some ions of the acid, but you will get a small amount of the ions because this is a weak acid. Now think about relative stability. Which one is more stable, ethanoic acid molecule or its ion? Certainly ethanoic acid molecules, because that is in larger quantity. 99% ethanoic acid molecule and just 1% or less than 1% is this ion. Now think opposite. So you are not adding ethanoic acid in water. You are adding ions of the ethanoic acid in water. So what do you expect to have now? Here are still two possibilities. One, the ions. Another, the acid molecules. So which one will be in larger quantity? Ethanoic acid molecule, because the molecule is more stable. And now how this forms? You look at this equation to see how this forms. Here you get the ethanoate ion, and that you got from the salt. The salt gives you this ion, and this ion combines with water because there's water. Combines with water, takes a hydrogen ion from water to form this acid molecule. So in the solution, you have this is small amount and this will be in larger amount. This is not a problem. This doesn't have any pH because this is acid molecule, no pH. Suppose. But what is this? pH will be higher because this is base. This is base. And so the pH will change. pH will not be 7. pH will be higher than 7. That's supposed to 12, 13 pH. And when I'm giving you another type of salt, which is suppose here I write ammonium chloride. Ammonium chloride. Look at this, ammonium chloride. So when you're adding ammonium chloride in water, the pH will change. Initially, you get this gives two ions, ammonium ion and chloride ion. And you know water gives H plus ion and OH ions. And here's chloride ion. What will happen to this? Nothing. Chloride ion doesn't react with water. But this reacts with water. Look at this, I write ammonium ion reacts with water, which is H2O, and will give you what? What does it give?
NH3 plus H3O plus.
Plus H3O plus. H3O plus. Molecule hardly affects the pH. So this is a molecule, though you know this is basic. This portion would be basic. This is base. So why shouldn't they affect us? When the base is alone, then that certainly affects the pH. But this base with acid, what is the acid? When you get this strong acid, then with the strong acid, ammonium molecule is nothing. Okay, so H plus, here's H plus, will dominate the solution. So pH will be lower. Okay, understand that? It's so simple. Now I ask you a question, why this happens? Why does this react? Why ammonia reacts with water? Why ammonium ion?
Because ammonium ion is less stable than ammonia.
Yes, thank you. I show you again this. Here's a beaker with water, and you are adding here ammonia. You know ammonia is a molecule, is a weak base, and as this weak base, so in water that remains as ammonia. Okay, ammonia. We write ammonia solution as ammonia NH3 aqueous. Okay, look how we write this ammonia, because ammonia is mostly ammonia. So when you're adding ammonia in water, then there's two possibility. What are the possibility? Ammonia itself can exist there, or ammonia can react with water to give ammonium hydroxide. The ammonia itself a possibility, ammonium hydroxide is another possibility. Yes, you get both of them together here in this solution, but you get ammonia much more than ammonium hydroxide because this is weak base. Now, let's compare the stability, relative stability. Which one is more stable, this and this? So as both are possible to be there, and you get ammonia mass more, than ammonium hydroxide, then certainly you can decide that ammonia is more stable, not ammonia. Ammonium ion in water. Here you still have two possibilities, that ammonium ion will remain there. As ammonium ion. Another possibility is ammonium ion will form ammonia. So this is the ammonium ion form ammonia. Okay, so which one you get more? Ammonium ion will form ammonia because ammonia is more stable. So look at this. this two ion, this ion and this molecule. So this is more stable, and more stable always happen. More stable things always happen. So this is less stable, which is the ammonium ion, and will convert into ammonia, and because this is more stable. So this is natural thing, that stable thing happens more. And so ultimately you are getting here H plus ion. Understand? You are getting here H plus ion. So when you get H plus ion, so that H plus ion will dominate the pH, not the ammonium one. And look at the previous calculation you got here. That is when you are giving here the ion of the weak acid. This is ion of the weak acid that converts into the molecule, because molecule is more stable. But a byproduct is important. Here is hydroxide. So hydroxide and acid, weak acid molecule. So weak acid is weak and this is strong because it is weight. So weights will dominate the pH of the solution. So here you will get the pH changes. pH changes, and also get pH changes when you have this. And no pH change when you have a strong sodium chloride. I hope you understand this. Can you categorize the types of all the salts? Here I'm giving you only 3 examples, but if you have many salts, thousands of salts, and how to categorize them?
Salts made from strong acid and strong base are neutral salts. Salts made from weak acid and strong base are acidic salts. Sorry, are basic salts, and salts made from weak base and strong acids are acidic salts.
So I write here neutral salt, and I'm going to write here acidic salt solution actually, and I write here basic salt. So basic salt solution. Look carefully. So when you get neutral salt, then why is the neutral? When is the neutral? When the salt is made from strong acid and a strong base. Strong acid and a strong base. Strong acid and a strong base. I gave you example was sodium chloride. So you got the example sodium chloride. Sodium chloride. How is sodium chloride formed? Sodium hydroxide. Sodium hydroxide is a strong base, and hydrochloric acid, which is a strong acid. So this salt is formed from a strong acid and a strong what? A strong acid and a strong base. So this would be neutral. Now get for acidic salt. Okay, acidic salt. So when you get weak base plus strong acid, a salt made from weak base and a strong acid. I'm giving you example. Weak base is ammonia and strong acid is hydrochloric acid. So salt is, you get ammonium chloride. This part is weak part. This part is from weak part. So this will react with water and to form hydrogen ion. And now get this example, basic salt solution. This would be weak acid. This would be weak acid and strong what? Strong base. So example is CH3COOA. Base here sodium hydroxide. Okay, you understand this three together, and this will happen. And I never suggest you remember them. Look carefully. I never suggest you remember them. I suggest you be tricky. How is that? Look, when you get an ion in a salt with covalent bond, an ion with covalent bond, how many do you get here? How many? They are ammonium ion. Ammonium ion. And here we get CH3COOH ion. For this to our clue, I suggest you the best way. This is how I studied. And you will be creative. You don't need to memorize so many things. Just always remember, focus on if you get any ions with covalent bond. Okay? And even then don't remember what will happen. And you will write equation. And after writing equation, you will write the products. So this is ammonia, this is H3O plus. So oh yes, this will be acidic. And now get this, CH3COOH and then OH. Oh, basic. More than 7? Fine, thank you. You again read this. I suggest you read this. pH of salt solutions of a strong acid and a strong alkalis. Both are strong. then pH is usually 7. Also, it depends on pH, temperature, because none of the ions react with water. So this is the cause. And then get this pH of salt solutions of weak base. Weak base and strong acid is below 7. I suggest don't remember this. And write the salt that you have and break the salt and you get this ion. This ion looks complex, and write an equation with water and you will get this, and so you will understand. No.